Lecture 7.
On axial skeleton, and then you should be able to complete lecture 6 on the appendicular skeleton. That will finish all the material on Unit 1 exam, which is a week from today. So the Unit 1 exam will cover lectures 1 through 6. So we don't get behind lecture 7 that we present on Thursday, but it won't be covered on this exam. I always have my exams on Tuesday, so you have the weekend to have enough time to study. So anyway, I didn't want to have the exam on Thursday. So the exam will be next Tuesday on lectures 1 through 6. On Thursday, I'll also have some comments about the exam or what to prepare and so forth. And then we'll go ahead and do the eye clicker today, which is the beginning of the lecture. So if you want to get your transponders out, we'll begin with that. So these are questions mostly over the axial skeletal system. So the first question. Okay, which of these structures represents a caniculi? Try and get rid of there. Whoops, is it still going? Yeah. Whoops. Okay, so go to 45. That's probably almost everybody. Oh, still some people coming in. Couple more seconds. 5, 4, 3, 2. Okay. And see what you responded. Most everybody, 86% put A, and caniculi are those little things like right there, so A is the correct answer. So there, I couldn't get that thing out of the way there, but anyway, there are these little things right there. Okay, number 2, the lamella are labeled in the diagrams by which of the letters? Lamella. Okay. A couple more seconds. And see what you did. Almost everybody chose letter C, which is correct. I have them all indicated there. Okay, the third question. The shaft of long bones is termed what? What's the name for the shaft part of a long bone? Okay. And A was right, almost everybody got it. Number 4. The occipital bone is labeled with which letter? Occipital bone. Okay. That's pretty near everybody in the class. Okay, and then the last one I should find out what you did. Everybody, 92% got it. Letter B is correct, of course. And number 5. Oh, I didn't start it for that. Okay, 5 seconds. Okay, not everybody, it was 150 before, I don't know where everybody is. Okay, and everybody probably got it, pretty close, yeah. 96%, it's the squamous. In the past, I have kind of ridiculous to have those 10 questions on you because you brought up the chart sitting in front of me. But anyway, on the exams, in the past, I've let the labs do most of the testing, but there's a significant amount of students in the class not taking the lab these days. So I have put in some text questions on anatomy, meaning they're just word questions like the last one. And I probably will have a couple figures, but I'll let you know what those are on Thursday's review if I do have figures. So I have started putting a little bit more anatomy on the exams because of the fact that not everybody's in the lab, and this is an A&P class. Okay, so let me go ahead and get started then. So we quit right as we were starting the vertebral column, so let me begin from there. Of course, that forms the vertebral axis, holds us upright in posture, and it's composed of block-like bones, which we call vertebrae. They're actually the family of irregular bones because they're so complex in shape, but they're kind of block-like bones. And they're separated, of course, by a fibrocartilage disc that gives us a protection from fracture of these vertebrae when we're jumping up and down. The primary purpose, besides giving us flexibility, is to protect the spinal cord that goes down the vertebral foramen. So it goes down through these bones and quite soft tissue, and we're protecting it in that bone encasement. There are regions of the spinal cord that are either called curves or just regions. The cervical is the first curve, which of course is the neck area, the thoracic that goes through the thoracic area, the lumbar curvature, and then the sacral curvature. And the lung and the vertebrae are indicated or named from the names of these curves. So there's 7 cervical
vertebrae 1 through 7 up here. There's 12 thoracic and 5 lumbar, and then a sacrum and a coccyx. So that makes up the 26 bones that comprise the column. The vertebrae, and there are a little bit differences between the cervical vertebrae and the lumbar vertebrae, but they have several classical parts that we always have you learn. So this represents a typical vertebrae, and the main column of the vertebral column is the body. It's a sphere kind of structure, a cylindrical structure that's part of the vertebrae, and between each of the bodies is the intervertebral disc. So this part right here is called the body. The vertebral foramen right here is where the spinal cord goes through, so that's a very significant structure. The spinous process is a appendage that comes out straight behind or posterior the column that you can actually palpate or feel along the person's back, where the transverse processes do exactly that. They come out transversely out each side of a vertebrae. The lamina, which I'm surprised is not labeled on this figure, so I put a little arrow, forms what we call the roof of the vertebral arch. So the vertebral arch is all of this bone that extends above the vertebral body. So the body is here in purple, and the vertebral arch is composed of the lamina, what we call the pedicle, and the 3 processes, the true transverse and the spinous process. So that whole thing in yellow is called the vertebral arch. It's an arch that goes over the top of the spinal cord. The pedicle supports the arch, so those are those little here, they are labeled. They're the 2 sides that hold up the arch. The intervertebral disc is that cartilage disc that I mentioned before that provides cushion so that we don't fracture the vertebral column if we bend it or cause too much distortion of it. And a very important structure that we sometimes skip over is called the intervertebral foramen, and that's a transverse hole, if you will, that goes into the spinal cord, and that's where the spinal nerves come out. We'll talk about that a lot in the second part of this semester, but the intervertebral foramen is the exiting point or entry point for spinal nerves that we'll talk about later. The very first vertebrae has a special name because of its position. It's called the atlas, and we always remind students that it was named because of the Greek god Atlas that held up the world, but it's the first vertebrae, and it supports the cranium. And the second vertebrae is called the axis because we can turn our head somewhat on that axis. The axis is actually a bone kind of out-pocketing that comes out from the axis and goes up that the atlas articulates on, and that little process is called we used to call it the odontoid process, but they've shortened it now. Most people are calling it the dens, but that's the process that comes out from the axis that the atlas articulates on. The most inferior part of the spinal cord is 2 large fused bones. The first is called the sacrum, which was originally 5 vertebrae that fuses as we age. So by the age of 18 usually, and some later, is fused into 1 large bone, which we call the sacrum. And the coccyx is 4 fused vertebrae, also by the late 20s, that are all fused, sometimes called the tailbone. The thoracic cage is a cage, literally, of ribs that surrounds the thorax and protects the lungs and the heart, and is composed of not only ribs, but it's encircled by, on the posterior, the vertebral column, and on the anterior, what we call the sternum, and then a large part of it is composed of cartilage, which is modeled here in dark. So this darker colored modeling is the representative of the costal cartilage. The sternum is also called the breastbone, and it's that bone that's right in the anterior central part of your breast. And it's composed of two large portions. The most superior portion is a kind of a square bone called the manubrium, which is represented right here. And just inferior to that is the junction between that and the body, and that junction is called the sternal angle, which is very easy to palpate, and you can feel it right on the top part of your thorax. And we use it as a marking point for placement of electrodes for EKGs and so forth, because it marks the junction between the first and second rib. So if you feel that sternal angle, that's where the space is between the first and the second rib. The bottom part, or middle part actually, to be specific, of the sternum is called the body. We used to call it the gladiolus because it looks like a gladiola flower, but now they call this the body. So the manubrium, the body, and finally a very small extension inferior is called the xiphoid. So the sternum is actually made up of three portions: a manubrium, a body, and a xiphoid. Some people call it xiphoid process. The ribs are divided into three categories. There are 12 pair altogether, but they're divided into what's called the vertebrosternal, which they call the true ribs, the vertebrochondral, and the vertebral. Some people call B and C both floating. But true ribs mean they go supposedly all the way from the vertebral column to the sternum, although there is some cartilage. The vertebrochondral go between the vertebral column and cartilage, and the floating ribs are just little extensions out from the vertebrae, the last two vertebrae that don't go all the way around the thorax, so they call them floating ribs. So there are 7 vertebrosternal. You can see them labeled very nicely, 1 through 7. And all of them extend from the vertebral column and then through a little piece of cartilage connect to the sternum. There are 3 pair of vertebrochondral, and so that would be 8, 9, and 10, or excuse me, 8, 9, and 10. And so they come up hooked together by a cartilage and then hooked to the cartilage of the 7th rib. So the 7th rib on up, all hooked to the 8, 9, and 10. So they call it vertebrochondral. And then the last two, 11 and 12, are floating and don't hook to any of the sternum by any process. Also, and we kind of overlook it a lot, part of the axillary skeleton are 3 very small bones called the auditory ossicles that are in the middle ear. And we have some models of those in lab that are actual size that are kind of interesting. But they're located in the middle ear between the tympanic membrane and the, we'll talk about last time, or when we get there, but the inner ear that we use for a transducer for sound. The one that's against the tympanic membrane we call the malleus. Then there's the bridge that goes between the malleus and the incus, which we call, or malleus and the stapes, which we call the incus. And then there's this little stirrup-shaped bone that's underneath the muscle right there, the tensor tympani, that's connected to the oval window that's called the stapes. So the malleus, the incus, and the stapes are the 3 little inner ear bones. Also, we usually present in this class the fontanelles and their names. So once again, these are intermembranous bone that's gradually converting to part of our cranium. And these are the soft spots that they talk about when your newborn is just born. Tell you to be careful. The anterior fontanelle is right in the midpoint of the coronal suture. The posterior fontanelle is represented right in the back. It's at the, here it is, at the back of the along the lambdoidal suture. The sphenoid fontanelle is the anterior part of the squamosal suture, and the posterior part's called the mastoid fontanelle. So we usually refer to 4 different of these soft spots of the infant as fontanelles. Okay, so that's all that's in that lecture. Let me go get started on the other lecture, which is number 6. Whoops. There we go. So this is called the appendicular skeleton, and it not only includes the bones of the upper and lower appendices of the arms and legs, but also the bones of what we call the girdles. There's a girdle that supports the upper appendices, which we call the pectoral girdle, and the pelvic girdle, of course, supports the lower appendices. And there's 126 of these bones listed right here on the left of that skeleton. Also, we're going to just briefly talk about the differences that exist between male and female skeletons. Okay, so the first bone that we'll start talking about as far as the pectoral girdle is the clavicle. It's an S-shaped bone that forms the superior and inferior part of the thorax. It's this little bone that you can feel across the top of your thorax in the anterior aspect. I always think of the clavis, C-L-A-V-E-S, clavis. When I think of this, that's a musical instrument of 2 small dowels you clink together when you are a percussionist. But anyway, it looks a little like this clavicle. It's a very small S-shaped bone. On the lateral side, it articulates with the scapula, as we'll show you in a minute, and the medial with the sternum that we just showed you a minute ago. So it bridges, as you can see, if this is a little larger, it bridges from the sternum to the scapula. And you can see here is where they call it the sternoclavicular joint on the medial aspect of the clavicle, connects to the top of the manubrium, and the lateral part of the clavicle connects to what we call the acromion process of the scapula. So they call it the acromioclavicular joint. Anterior superior thorax. The posterior superior thorax is composed of a bone that makes up the rest of the pectoral girdle. It's a large triangular bone called the scapula, or some people call it the shoulder blade. And it's got several different parts that we always present to students. The articulation site, the fossa that the humerus articulates in, is called the glenoid cavity. So that's represented, made it blue, representing the cartilage that covers it. But anyway, that's the glenoid cavity. The coracoid process extends behind that and is an attachment site for muscles. The acromion process we already mentioned is the lateral articulation site for the clavicle. The medial margin, and this is kind of interesting and gets students confused, but this is the medial margin, which is also sometimes called the vertebral, which is right here. It's definitely towards, it's medial in the body. And the lateral margin or border is also called axillary because it forms kind of a triangular area that's called the axilla of the skeleton. So that would be right in here, the axilla. So that's often called the axillary and vertebral border. But those are the medial and lateral margins of the scapula. The spine is a process that extends from the posterior side outward, kind of a rib that extends out from the scapula. And the 2 large points are called angles. So the most superior part of the scapula is called the superior angle, and then the inferior angle is the most inferior part. And finally, there's there it is, a suprascapular notch that's on the superior side about halfway across the scapula. So that's the pectoral girdle and what we want you to know about those two bones. And then the humerus, and there are more processes to all these major bones, but I'm going to focus on a couple processes, but mostly on their articulations in this class. So the humerus is obviously the longest and largest bone in the upper extremity. It articulates proximally with the scapula, just mentioned in the glenoid cavity, and distally with both the lower arm bones, the ulna and radius. They're, medial and lateral condyle and so forth. I'm not going to have you learn those. If they do in lab, that's fine, but that's all I need you to know. The ulna is the larger and longer of the two lower bones in the arm. It's longer than the radius, and the extension is a process called the olecranon process, and that makes up the elbow. It's represented here. So proximally articulates with the humerus and the radius, right here, and distally it articulates with a group of bones in the wrist called the carpals, and it also, again, articulates with the radius. As far as remembering, I think it's hardest for students to remember what's a medial and lateral bone, and a lot of these exams, anatomy exams ask you, is the ulna lateral or medial? Anatomical figures are always with the palm forward and the thumb outward. And I don't know if it helps you to remember, but the radius turns radial, well, that's how I remember it. The radius turns in the lower arm, and it's on the thumb side. So it's the more lateral of the two bones, and the ulna is the more medial. That helps you a little bit. So the radius is on the lateral side of the lower arm. Proximally, it articulates with the humerus and the ulna. And again, it's kind of got a rounded articulation site, so it can kind of turn, if you will, or bevel on the ulna. And it also articulates with the humerus, and distally articulates again with the carpals and the ulna. The carpals are some small irregular-shaped bones. There's 8 of them here that make up the wrist. I'm going to not bother you to remember all the scaphoid and all those little names. The labs can teach you this when you have the bones in your hand and you're manipulating, so it's a lot easier. So I won't ask you any questions involving those carpals. The metacarpals still are part of the wrist. In fact, their heads are, the palm is a better term. Their heads make up the knuckles. They're out here are the knuckles that begin the fingers. They're numbered 1 through 5, with 5 being the thumb side, 1 being the thumb side and 5 being the little finger. And they extend out to the end of the palm, and then these out here doesn't look like it, but these begin the fingers. And the finger bones are called phalanges, as interestingly are the toe bones also. There's 14 phalanges, and they're also numbered 1 through 5, proximal, middle, and distal. And the 1, again, would be the first phalange, and it only has a proximal and distal. That's why there are only 14. So there's only 2 phalanges in the thumb, and then there's 3 from the pointer finger, if you will, from the second finger onto the 5th. So there's 3, 3, 3, plus 2, so that's 15 total. Okay, so that finishes the bones of the upper extremity, and all we have left is the lower extremity and girdle. And we'll start out with what we call the pelvic girdle, which is one of the more complex. It's almost as complex as the skull, if you will, and it has a lot of importance as far as supporting us being upright, walking organisms. Altogether, the pelvic girdle is called consists of 2 os coxae bones, which are these large bones that make up the side. The sacrum, which is the inferior part of the vertebral column, and finally the coccyx. All of those together make up the pelvic girdle. So we've actually talked about the inferior part of the spinal cord or spinal column already. So we're going to focus on call this the os coxal bone, and and together they're called os cocci for pair. They unite anteriorly, this would be anterior, at a little patch of cartilage called the pubic symphysis, so that's right here. And they unite posteriorly and articulate with the sacrum, or what's called the sacroiliac joint. So posterior, they hook onto the sacrum, and anteriorly they come together at the pubic symphysis. Interestingly, the os coxal bone developmentally begins as 3 different parts, and we still talk about these parts as far as naming not only the bone, but the structures within it. So the majority and most superior part of the bone is called the ilium, and developmental-wise, that's a separate bone, but as we age, it fuses with an ischium, that's the most posterior and inferior part of the os coxal bone, and the most anterior is called the pubis. So there's the pubis, the ischium, and the ilium. They fuse by the time we're in our young teenage period. There's a large ball or socket that the ball of the humerus the femur articulates in, called the acetabulum. So this is the acetabulum articulation site. And interestingly, it's made up of all 3 of the contributing bones of the os coxal bone. It's made up of the ischium, ilium, and pubis. The largest foramen in the body is called the obturator foramen, and it's right here. You read in some anatomical books, it's some ligaments and muscles pass through there, but most people that are experts in anatomy say it's covered by a membrane, which is an attachment site for muscles. But anyway, it is a very large foramen called the obturator foramen. So what I'm going to do is look at the major processes that are part of this os coxal bone, and we always do this by going through the different parts of the os coxal bone one at a time. So I'll start talking about the ischium, and each time I'll talk about the major parts of the ischium. So I talked about, or defined the term tuberosity when we're talking about bone processes. It's a roughened area, and the only major feature of the ischium is the ischial tuberosity, and that's what we sit on. So we can always easily remember that it's roughened, and that's where we sit. There is a small little process above the tuberosity, a little outpocketing that they call the spine or ischial spine. And then below that is the lesser sciatic notch, and you've probably heard about the sciatic notch, and above that is the greater sciatic notch, which we, I think, refer to in another bone. The pubis is, again, the anterior part of the os coxal bone on the left in this figure, and the site where the 2 os coxal bones come together is the pubic symphysis, and that's all we usually have you remember as far as the pubis bone. And the ilium by far has the most features. The very large crest-shaped top of the ilium, which you can feel, palpate on people. The most superior part of the os coxal bone is called the iliac crest, indeed a very large crest. And the anterior part, which is on the pubic side, is called the anterior superior spine right there, and easily remembered. The inferior is called the inferior superior spine. So on each side we have a spine. This anterior superior and anterior inferior, and then there's this posterior superior and posterior inferior. So there's 2 spines on each side. I said it wrong. And this is the posterior and inferior superior, the posterior superior and inferior, and the anterior superior and inferior. And I mentioned before the greater sciatic notch, which is really part of the ilium, unlike the lesser. And that's all. So anyway, those are the major parts of the ilium that and most people would have you remember. And I'm sure that they'll do the same thing in lab that I went through here. Okay, and then that gets us to the bones of the lower extremity, the legs. By far the longest and heaviest bone in the body is the femur, and it has a very large head that articulates again within the acetabulum of the os coxae, and then the most distal part articulates with the tibia. It has two condyles that articulate with the tibia bone. The kneecap is the small shaped triangular called the sesamoid bone we talked before. That's anterior to the knee joint, and it kind of protects the delicate structures of that articulation. We have the next lecture is actually a whole lecture on articulations and the classes and the parts of articulations. It won't be on this first exam, but that's what the next lecture is about. The two lower bones are the tibia and fibula. The larger is called the tibia, much larger and represented here, and the thinner one that parallels that is called the fibulas, tibia and fibula. And you'll notice, first of all, kind of interestingly, that the tibia proximally articulates with the femur and the fibula. So it's got these two condyles that articulate with the femur bone, but notice that, as we'll show you in a second, the fibula does not go up and contact the femur. So only the tibia articulates with the femur. And distally, the tibia articulates with a large bone in the foot called the talus, which we'll show you in a second. The fibula, which is the more lateral of the two, it's lateral to the tibia, the fibula, articulates proximally only with the tibia once again, it doesn't go all the way up to the femur, and it also articulates distal with the talus. And now we get to the bones of the foot. The talus, unfortunately, in this figure is behind the figure, but that's the articulation site for lower leg bones. And this large bone on top of it in this figure is a calcaneus that makes up the heel. So the talus articulates with the lower leg. The calcaneus is the heel bone, and then there's 7 other and called tarsals. They're very close to the same kind of organization as carpals in the hand. And again, I won't have you learn all the names of those, although they probably will in lab. And then just like the hand, there are metatarsals, like metacarpals in the hand, 1 through 5, that make up the major part of the foot. And then the toes are made up of 14 phalanges, so it's easy to remember, just like the hand bones. So there's 2 in the big toe and 3 little tiny bones in the toes. For toes 2, 3, and 4, there's a proximal, middle, and distal phalanx, just like there is in the hand. So, pretty easy story, and most of you probably know the major structures already. The last thing I wanted to do is go through the difference between male and female skeletons, and this is indeed how pathologists, when they find skeletons, can figure out their sex, and it's mostly done by the os coxal bone, as is shown here. So generally, the bones of the male are heavier and larger, whether it's an os coxal or femur or anything. All of them are heavier, and the points where primarily tendons attach are much larger. So a trained pathologist can just look at almost any of the major appendicular bones and just tell me because of their girth and attachment site, whether it's male or female. But the os coxal bone has some very distinct features that distinguish the male from the female. By far, one of the most distinctive is this angle. It's called the pubic arch. And the male, it's less than 90 degrees, and the female, it's 100 degrees or greater. So the pubic arch is much wider, more obtuse, and the male is more acute. There's a large, they call it the brim, some people call it another name, but the large opening from the pelvis that we use for birth canal in females is very usefully much larger in the female and oval. So the pelvic brim here is the diameter is larger and it's more oval, as you can see, than more round, where the male is actually looks kind of oval. Although I said larger and oval, I think the female is much rounder. The acetabulum is more anterior, and this figure doesn't show it very well, but the articulation site for the femur is more towards the anterior portion in the female than the male. The obturator foramen, and it differs by author, so I added that little comment. Often they say the male is oval and the female is triangular, but the male I think most people call oval, although there's differences in authors again, but the female doesn't seem as long and as round and almost triangular. So although you'll see a difference in descriptors, you can see this definitely looks longer than the one in the female. So I think that's the major things I wanted to do. So